So in this video I'm going to be talking about absolute maximums and absolute minimums. We're going to need to look at a graph first. So here I've graphed a neat little cubic here. This is the equation of that cubic. I'm just going to copy and paste this so we can start drawing on it. So this is our cubic function right here. Now let's talk about the maxes and mins. Now when you look at the maximums and the minimums, you might be thinking of turning points. And you might say, well, there's a turning point here and there's a turning point here. And this is the max and this is the min. But that's only half right, because this isn't the absolute maximum. This is what we call a local maximum. It's the maximum in a certain domain. And this is what we call the local minimum. It's the minimum in a certain domain. The absolute maxes and mins for this particular function are way up here at positive infinity and way down here at negative infinity. Now this feels a little bit strange, and this isn't generally how we talk about absolute maxes and absolute mins. So to talk about absolute maxes and absolute mins, we usually deal with restricted domains. So this is the same graph again, but this time I've restricted the domain. I've restricted it between negative 3.5 and 0. That's arbitrary, that's just what I've decided to do. Now, this time we can look at the absolute max and the absolute min. The absolute max is just the highest this function ever gets. And the highest this function ever gets is right there at that turning point. So in this case, the local maximum is also an absolute maximum. It's the highest we ever get. Now, the absolute minimum, though, is this number down here. That's our absolute minimum. It occurs at x equals negative 3.5. Our local minimum, that's one of our local minimums at this turning point, but it's not our absolute minimum. So, the upshot of this is that when you're talking about absolute maximums and absolute minimums, you need to consider two different things. You need to consider the turning points and the boundaries of your domain. You need to go either side to determine where is the absolute highest point and where is the absolute lowest point. Now, I've been talking in generalities and just talking about graphs in general, but we should really do an application, because that's where this is most important. Alright, so here's a question here, and here's a little guide for these sorts of questions. So, read the question, and then we'll talk about it. So, important things to note here. We have a function, but we also have a restricted domain, and both of those things are important. Now, this question is tech active, which means I'm just going to be able to use my calculator and look at this graph with this restricted domain. So, if you don't know how to restrict your domain on your calculator, here's how we're going to do it. First, we type in the equation that we want. This is the equation that we want. Now, when you want to restrict the domain, you go control, this equal sign here, and you use this such that button here. Alright, and now let's look at how I want to restrict my domain. We want x to be between 0 and 20, including 0 and 20. And that's going to be really important that you write in including, if it does include. Back to our calculator, the function such that 0, control this one, less than or equal to x, control this one, less than or equal to 20. Okay. Now let's just zoom appropriately into this thing. And you'll see what the graph looks like when we do that. Oops, let's try again. Alright, not quite there, not quite what I want to see. Let's keep going, zooming. Ah, there we go. Alright, you can see that my graph is restricted between 0 and 20, and that's what we want. Now, when it comes to absolute maximums and absolute minimums, here is my absolute minimum, and here is my absolute maximum. You can see that they're at the domains. There's a turning point here, and there's a turning point here. Because it is a cubic, we can see that if we do that. There is a turning point there and a turning point there. They're local minimums and maximums, not absolute minimums and maximums. So the question was, how many computers should you sell weekly for a maximum profit? And the answer is this number right here, 20. You should sell 20 computers for a maximum profit. Now, if you want to know what the maximum profit is, you do a little trace here, type in the number 20, and we can see that the maximum profit is $436.66. So it is really important when you do these questions that you check what is the question asking. Is it asking me to find the X value where the absolute maximum is, or it is asking me to find the Y value where the absolute maximum is? Now we are really lucky here because this was a tech active question. If this was a tech free question, you've got lots of work to do. You need to find and classify the stationary points. So find the first derivative, let the derivative equal 0, figure out whether they're maximums or minimums, possibly by doing the second derivative test. But then you also need to test the boundaries by subbing in 0 and 20 in this case, or whatever it is that those boundaries are, subbing in those boundaries and figuring out whether those values are larger than the maximum or the minimum, or smaller than the minimum, depending on whether you're trying to find maximums or minimums. So it means that not only are you thinking about the stationary points, you're also thinking about the boundaries and testing those as well as testing your stationary